Hi, everyone. Welcome back to again today. If you have any technical issues, please send a private chat message to Jen and Britt to troubleshoot. You can find Jen at the top of the participant list in the host section. If you're having trouble seeing the presentations, please refresh your browser. Your chat tab will automatically be open to the general chat. Please use the general chat for general discussion and words of encouragement for the speakers. Clicking the back arrow will take you to the full chat list where you can chat with anyone at the table you're seated at or privately with an individual in the lecture hall. Our panel today will have a live moderated Q&A. To participate, you can type your question into the Q&A box on the right, making sure to specify who the question is for, or click raise hand to be brought on stage to ask your question verbally. Feel free to upvote the typed questions that you see on the list to move them upwards. Please submit questions at any point during the panel so we can get to as many as possible in the time allotted. To exit the lecture hall, the link to the lobby is posted in the general chat. Please also note the agenda icon on the right-hand side of the top bar. It's open not to see the full event schedule for the day shown in your local time zone. Thanks again. We'll go ahead and begin with our welcome back remarks.
Good morning, everyone, and welcome back to day 3 of our workshop on exemplary admissions practices that promote diversity in engineering. I hope you're all enjoying the workshop over the past 2 days as much as I am. I have learned so much from all of you. Yesterday, from our first group of panelists, we learned about successes and challenges faced by 3+2 year transfer programs. We learned that while successful course numbering is important to smooth transfer processes and transitioning from one institution to the other, it is still important that fields of study between 3+2 year transfer programs are aligned so that students do not have to retake courses when they transfer to the school in which they are going to earn the engineering degree from. In addition, it is important to understand more about how previous and current institutions meet the needs of unique types of students. One panelist from the first panel yesterday pointed out that math aptitude remained one key challenge to overcome in transitioning into becoming a successful engineer. Another panelist pointed out that we must meet learners where they are. The second panel discussed elements of best practices. Some key highlights of best practices in admissions that promote diversity in engineering include summer bridge programs, where there's a high first-year retention, somewhere typically above 95%, and a high final graduation, 6-year graduation rate from having those programs with diverse students and all the support services. Number 2, the use of the concept of the athletic red shirt program to meet learners where they are and advance them to successful careers in engineering. Several of our speakers spoke to this really interesting program and a way to really advance engineering students where they are. Number 3, the alignment of financial aid offices and enrollment management to ensure successful matriculation where finances are not the issue for successful completion. And number 4, providing important human-centered support services, including mental health resources to support underserved and underrepresented populations to ensure their success. One panelist pointed out that it's not how long you take, but it's that you finish. The third panel focused on research insights that might inform better admissions practices going forward. Key highlights of this group was the concept of holistic review. In the first talk yesterday, one of the panelists spoke about self-examination of the admissions process to remove elements of bias. Others spoke about holistic application review and careful design, diversity being one component of merit. One panelist talked about a framework, leadership, extracurricular activities, trends of grades, but not just absolute GPA, but trends of grades. Of course, letters of recommendation and unique circumstances and challenges that the individuals overcame, sort of the concept of grit and perseverance and a way to measure that. And then finally, Dr. Posalt, Julie Posalt, spoke about 4 elements of holistic application review, including comprehensiveness, contextualization, systematicness, and equity-mindedness. Several challenges were discussed, including the fact that holistic review tends to be very labor-intensive because it involves the operation done by humans. In addition, having admission officers, faculty, and administrators come together to agree on acceptable metrics for holistic evaluation was also a key barrier to change. Today, we're going to bring an element to our admissions and enrollment management that involves the application of technology, including artificial intelligence and machine learning and data science. I would now like to introduce my colleague, Dr. Andrew Williams from the University of Kansas, who will be moderating the next panel session.
Good morning. I'm Andrew Williams, Associate Dean for Diversity, Equity, Inclusion at the School of Engineering for the University of Kansas. I'm excited to welcome you all to the panel on AI, data science, and machine learning in recruiting, admissions, and supporting retention. We're fortunate to have leading experts on this topic. There will be, I would like to remind you that there will be a breakout session after the break, and the discussions will center around barriers to using these tools, other tools, and envisioning the perfect admissions system. We hope that the discussions and report backs will help inform our future work in engineering education. So we want to encourage everyone to participate. The speakers that we are fortunate to have today are Brad Weiner from University of Colorado Boulder, Michelle Winningham, University of California, Santa Cruz, Conrad Tucker from Carnegie Mellon University, and Kirsten Martin from University of Notre Dame. So first, we'll have Brad Weiner, Director of Data Science, Office of Data Analytics, University of Colorado Boulder.
Hello, everyone. Good morning for those of you who it's morning. And if it's not morning for you, then happy day. We'll go ahead and get started. I'm delighted to be here today. And I'm going to share a presentation with you all that I finished, I will tell you, very recently. So if there are any mistakes, I'll get those fixed up right away. Let me make sure I'm in the right spots. All right. So hopefully everyone can see this. I'm a little bit at a loss to be able to see other information right now, but today I'm going to be talking about data science as a flashlight. And I know that it's a fairly common conversation for us to have in terms of models being biased or models not working well, but models can also point the way. And so I'm here to sort of advocate for that viewpoint. So really quickly about me, I'm the Director of Data Science at the University of Colorado Boulder. I've been in higher ed for 20 years or so. I'm easily Googleable, but I have worked on a number of different college campuses as well as the ed tech space. And I've been doing data science for more than a decade. You can contact me at the information below, and I really look forward to hearing from you. So today I'm just going to set the table a little bit. What is a predictive model? A predictive model is an equation, and it is built on historical data. So this is where you need to be a little bit careful. And this estimates the likelihood of a future outcome. So here's a little mental model to help everybody kind of understand the space we're talking about. You take historical data, and then you feed it into an algorithm, and then that algorithm produces the equation. And then you take new data, which I refer to as out of sample data, you put that into the equation and you get new predictions. So let's talk about how this could potentially work for you. Why do we use this in higher ed? And I'm extremely, I'd really like to advocate for this point that we want to use our resources as efficiently as possible. So colleges and universities are in the public trust. And as we've learned recently, the overall perception in the public trust of colleges and universities in America is declining. We don't, at least currently, have the capacity to provide customized interventions for each individual student. And our research, teaching, and public engagement missions depend on us to fairly and efficiently allocate our resources. I would also like to argue that if we don't use data or existing research, like we heard from the panelists yesterday, then we're guessing. And if we're guessing, we are going to be biased toward the status quo. So how do we use predictive models effectively and fairly? There is obviously a ton of discourse on this, and I believe that my colleagues on this panel are going to discuss this in greater detail later, but I have a few guideposts for everyone. First of all, understand the use case. Are you predicting success or are you predicting failure? Assess the risk of your model. If there's a chance that this would deny someone opportunities or create a space where resources are getting allocated to the wrong people, then just don't do it. Specify the model transparently and test for accuracy. Train users on intended uses and avoid off-label efforts. These happen a lot where people go, oh, you built this model. Can we use it for this or that? And the answer should be no. It should always be used on the outcome that was intended. Align incentives and organizational structures with your outcome, which is really important. And I believe others are going to be talking about that. And then learn to point the outcome toward populations of interest. Models aren't inherently bad. It's how we use them. And so if we want to enroll and retain more, say, BIPOC engineers, then let's use the model as a flashlight to find and help those students. So let's do this really fast, okay? We're going to go ahead and predict retention. Now, this is an example. It's going to be done quickly, and it's not real student data. So let's just walk through this quickly. Here you have 6 student records. It has sort of their income group, their biological sex, their age, and a number of data points. Then what we're going to do is pre-process the data in order for the algorithm to sort of, utilize this model properly. We need to normalize the data, and we need to dummy out some of the variables. We split into training and test sets, and then we build a model. So let me show you what's going on here. This is a basic regression model that is going to predict the likelihood of retention based on the total number of peers a student has on campus, the net tuition that student is paying, whether or not the student is a female, and whether or not the student is in the group that is receiving no institutional aid. And then what we get is a model. And so here's the interpretation here, just so you can all take a quick look. Again, this is not student data, so I want to point you to that. But students who are in the no aid group at the very bottom are about 3 times more likely to retain than those who are in the baseline group. And females are about 18 times more likely to retain than the same population. So then what you do is you make new predictions. This is a basic histogram of the distribution across the bottom. The gold students are the ones who are least likely to retain. The green students are the students who are in the middle, and the blue students are at the top. And then we're going to go ahead and allocate our resources based on what this model shows. So I've broken those out into 3 buckets. Now, this is the important point. At this point, all we've done is built an equation. But here is where the equation transitions into an intervention. And so let me provide you a couple of scenarios. Option 1. We learned that aid is important, so maybe we take all students and we give the least likely students to graduate some additional aid. And we give the students in the middle some additional tutoring or support services. And then the students who are most likely, we give some communications or other sort of low-cost efforts. Another option, which is popular, I wouldn't necessarily advocate for this, but there is a world out there where people assume that the least likely students are not going to graduate, and so we shouldn't do anything for them. And there's also a world where people say, well, the students who are most likely, we shouldn't do anything for either. And then, of course, you could take everyone in the middle and allocate your resources that way. So this is another way of thinking about this. And again, I'm not trying to point toward one or the other, but this is sort of, this hopefully highlights the different ways that you can use this model to advance student outcomes. Let's look at it for engineers. Maybe your population is small enough and you just decide to throw out the model altogether and you say, irrespective of the likelihood, we're going to assign everybody some additional support services. And then maybe your population gets so small that you come up with a different way to throw out the model. And so let's talk about maybe BIPOC engineers. Maybe that's such a small group, or that group, your group has determined needs specific interventions. Maybe you come up with something totally separate for them. But in all 4 of these cases, we've sort of used data to hopefully highlight the different ways that we could approach this problem. And so I would ask, which option will you choose? And so to conclude, I would suggest that who succeeds in higher education is both structural. We have limits on classrooms, limits on lab space, limits on our capacity, but it's also cultural. We get in the way a lot of the time, and we have entrenched problems that we can fix just because they're cultural to higher ed. And as educators, we should appropriately use data to allocate our limited resources. And this means that we can reproduce the past, or we can create more opportunities in the future. Thank you very much. I will put the codes and slide up a little bit later, and I look forward to additional discussion. Thanks for your time.
Thank you very much, Brad. That was useful to see the step-by-step tutorial and illustration of building a model, and you made some great points. So everyone will have a chance to ask questions at the end. So next we'll have Michelle Winningham, Associate Vice Chancellor of Enrollment Management for the University of California, Santa Cruz.
Thank you so much, Andrew. It's truly a pleasure to be here with everyone today. I truly hope you've all had a wonderful workshop. I've been really impressed taking a look at the agenda. I've been in enrollment management now for about 27 years and have been at the Associate Vice Chancellor of Enrollment Management at UC Santa Cruz since 2007. I first want to give you a little bit of context about the campus, kind of how we read and score, and then share our history about the use of predictive analytics in various aspects on our campus. We are one of the youngest and most recent campuses to join the AAU. We have 17,000 undergraduates, 31% are underrepresented students, Latinx, African American, and American Indian. We have 35% of our students who are first generation and 30% who are Pell recipients, in addition to 2,000 graduate students. We are recognized as a Hispanic serving institution, as well as an Asian American, Native American, Pacific Islander institution, and in the top in the US for social mobility. So I just wanted to kind of share the context of the type of students we serve. And so we're really excited about what I think is the real value of bringing in a lot of first-gen Pell recipients with many first, second, and third generation students as well, from locally, nationally, as well as globally. At UC Santa Cruz, Admissions and Enrollment Management works very closely with our Academic Senate Committee on Admissions and Financial Aid. And so that is the committee that determines our policies and our selection principles. And I would say at Santa Cruz, we have exceptionally strong shared governance. And I loved what I heard earlier. And I think that we see the time that it takes with our holistic review and working with our Senate committee as really a responsibility to ensure that we're doing the very best on behalf of our students, as well as the many communities that we serve. We've gone from about 83% admission rate about 15 years ago to a 52% admissions rate most recently. And so we continue to work together and continue to learn and innovate. In collaboration with our faculty, we recognize and are very committed to doing our best to use our positions of power and privilege to leverage data as well as student insight to truly disrupt historical and systemic oppression. There's a keen focus on students whose background suggests that having an opportunity to study at a major research university will have a particularly strong and positive influence on the student's future. So we really, again, take pride in continuing to learn and innovate together. And I love what Brad said, to appropriately use and responsibly use our data. And so every application is reviewed by a reader that has to go through a certification process. And a student will get from a 1, which is the best score, to a 5, or a deny, all based on the rubric that our Senate committee has put together. The entire focus is truly the achievement within the context of opportunity, including the incorporation of non-cognitive variables, such as leadership. And the leadership isn't just at school or the community, it may also be within the home environment, resilience, as well as perseverance. Our faculty, and I don't know about all of you, have spent so many hours discussing what does achievement mean? And so it's really that beautiful discussion of really understanding and trying to push forward the goals of excellence and diversity. And they fully understand that, maybe a 3.7 student may be a higher achieving student than a 4.2, given how that student has taken advantage of opportunities in their particular school and in their particular community. And at Santa Cruz, we can't use race, gender, or ethnicity in our selection process. And then no individual student is admitted. Rather, we tend to use primarily our holistic review score and some other factors. And those factors can be related to particular groups of students, like eligible in the local context or a particular type of school. We've got what we call LCFF schools that have a lot of first-generation English language learners, foster youth that might be in those schools, and they might be lower resourced. So we may focus on that, as well as geographic neighborhood. We work with our economics faculty members, which are awesome, and we're really using census tract data as well as block data to, again, understand the context that the student is within. And then we also may use, sometimes I call it at the margins, a predicted first-year GPA. And so that's something that I'm excited to share a little bit now about the history of predictive analytics on our campus. And I think, for all of my colleagues that are here today, that admissions for decades and perhaps since the beginning has been truly about predictive analytics. That's why we have admission criteria, is we're looking at setting some expectations that we feel are necessary to ensure that students can be successful. And I always really think about it not just as students, but as our future alumni. And so we've been using this for really helping to meet our enrollment targets to make sure we don't go over or come under. So really those probabilities of a student accepting our offer admission, as well as the probability that they will enroll. And then I mentioned earlier, a student success indicator is what we refer to as typically a first-year predicted GPA or even a predicted retention rate. And so since 2011, we have been producing for every applicant this first-year predicted GPA. And I would share that we really use it at the margins, and it's very inclusion-oriented, not exclusion-oriented. And I think that's really important. One simple way that we've used it is even to determine who's going to get a second read. And so if you have a holistic review score of a 1, and all of a sudden we're seeing a predicted first-year GPA that's much lower, we'll take a second look at that with one of our senior evaluators. But also, our faculty are not interested in just going right down the holistic review score and saying, let's just take all the 1s and 2s, and that's where we draw the line. Again, we're trying to more fully understand the context of that achievement. So what we've done is utilize this predicted first-year GPA. If we go into, say the 3s or even the 4s, which are students who we know that can be successful, and the challenge for any of you at a selective university or a selective program is picking, among the best. And so we just, again, we're really trying to shape our class and use true enrollment management to achieve many of our goals. And so we'll use that as another indicator. So if a student has a holistic review score of a 4, we may also look for a predicted GPA of, a 3.0 or better, just to give us that additional confidence. But it's really to pull that student in and give them that opportunity rather than thinking of it as an exclusionary factor. And then on our campus, in terms of really thinking about the retention, using predictive analytics for retention, this has been a really hot topic. And one of the pieces I've been trying to do is shaping it to think that maybe it's a support service indicator, that maybe you can't, as an academic advisor, contact every one of your students, but maybe there's the 10% that you can find that really could benefit from a phone call as opposed to just an email, or maybe meeting with them in the first 3 weeks of the quarter as an example. So I think those are some of the key points I wanted to bring out just to give you enough information as we transition to Q&A. Thank you.
Thank you very much, Michelle. It's great points about using predictive analytics to be inclusion-oriented versus exclusion-oriented, and really working with faculty and shared governance. So next, we are delighted to have Conrad Tucker. He's the Arthur Hammerschlag Career Development Professor of Mechanical Engineering at Mellon University. He also has courtesy appointments in biomedical engineering, machine learning, robotics, the Scilab Security and Privacy Institute. Welcome, Conrad.
Thank you very much, Andrew, and it's a pleasure to be here. So today I'm going to be focusing on artificial intelligence, how it's defined, potential relevance to admissions and STEM education. So if we take a step back and think about the process of human learning, just in a very general sense, we have our senses that use to acquire data. We have our own biological model that we then use to classify and make sense of the world. Now, a lot of our feedback that we get as humans is either from our teachers or educators or from our environment itself. And so what we've done from an artificial intelligence perspective is kind of replicate this process where machines have artificial sensors, they acquire data, there's some type of predictive model, as was alluded to earlier, and in a similar way where people classify, we now have algorithms and machines doing similar tasks. And what I'm going to be focusing today on is this process of classification, because if you think of the admissions process or whether or not a student receives financial aid or predicting their GPA, this is a task of classifying. And the way that machines are getting feedback as it currently stands is from people, from humans. And one of the challenges is that we have to acknowledge the biases that exist within humans, with us, and how those biases may then translate to machines. So let's do a quick exercise to really illustrate this point. I know that it's through this video tool, so I'm unable to see hands being raised, but just keep a mental note of the questions that I'm going to ask you. So we're going to start off very simple. It's a very simple exercise. So if I were to ask you what this is, and I'll give you a couple of seconds to observe what you're seeing in front of you, and then make a classification. Now, some of you, hopefully, many of you would have said that this. Well, let's just keep a mental note. All right. So my next question is going to be the second object that you're seeing here, and if I ask you what this is, to keep a mental note. Now, the first object that I showed, many of you hopefully classified that as an apple or a picture of an apple, which is more literal in this case. Now, the challenge comes with the second object that I presented here. Now, if I were to kind of postulate based on other times I've shown this example, many of you, or at least some of you, would have classified the second object as a banana. And if you did that, it would be incorrect, because the second object is actually a plantain, has similar features compared to a banana, but there are certain geometric characteristics that are quite different. Now, what's interesting, I've done this study in international settings, and the solution is actually flipped. So most of the people actually classify this as correctly being a plantain. Now, if we look at what's going on in our brains, there were two objects that were shown, and there's something going on in our heads, synapses firing based on information that we're receiving, that led you to classify one of these objects as an apple or a plantain or a banana. Now, from an artificial neural network perspective, whenever we hear the word AI, for the most part, we're now referring to an artificial representation loosely related to what biological systems have, where you have some type of input. There are synapses or activations that have been represented in some type of mathematical form, and then there's an output, which in this case is a classification. Is this a banana? Is this a plantain? Now, if we take this artificial representation and map it to the college admissions process, so now we have algorithms that are trained on student data, and some of that student data may be the pictures or candidate profiles of our applicants. Some of those data may be the resumes that students have. And the final output is a classification of whether or not a student is accepted or rejected into a program, whether or not a student is provided financial aid or not, and whether or not a student will maybe have a GPA that exceeds a given threshold. Now, the challenge of these AI models, as I showed in the banana and plantain example, is that the ground truth labels, the way that the machines are actually learning, is coming from humans. And so we have to ask ourselves, what are the inherent biases that exist in the way that humans make decisions from data, and what are the possible risks of transferring those biases to these artificial representations of decision making? And what's even more challenging, in the same way that I could not go into your brain to see what synapses were occurring that led you to classify an apple or a plantain, it's very difficult to interpret the classifications of many of these artificial neural networks. Yes, we may have the activation of an artificial neuron, but what does that really mean as to a decision making? And is that satisfying to a student that was just denied financial aid as to what aspects or characteristics played a role in that? So these are some of the challenges that we have to consider, and hopefully we'll have more discussions in this panel. But I wanted to present the AI representation of this problem and highlight the fact that some of the challenges come from human biases and human decision making that may then translate to computers. So with that, I would like to thank you for your time, and I'll turn it over again to Andrew.
Thank you, Conrad. Great practical example and explanation of how our human and even machine classifications can be biased or even wrong. And we need to exercise caution as it relates to admission and retention. And I did think that was a banana, I confess. Next, we are delighted to have a world expert on AI ethics, Kirsten Martin. She's the William P. and Hazel P. White Professor of Technology Ethics, Professor of IT Analytics and Operations of the Mendoza College of Business, and the Director of the Notre Dame Technology Ethics Center from University of Notre Dame. It's your turn, Kirsten.
Thank you very much. Thank you very much for inviting me here. I'm excited to talk about this. It's something we use admissions AI in my class as an example, and it always gets the students very invigorated to talk about how they would design something along these lines. So it's interesting to talk about this in practice as well as a hypothetical that we use in class. So today I'm just going to talk about 4 items. There's a lot to go through with AI ethics, but these are 4 that really jump out to me when we're talking about different ways of using machine learning tools in recruiting, admissions, and retention. So one is, what are we measuring? What data does it take? How is accuracy measured? And could this program possibly be repurposed? And I'll talk about that last. So what are we measuring? There's a few things that we always need to be mindful of when we're thinking about these programs: that the outcome variable, the target that we're talking about, the data that we choose, the features, the data set, and I would even include the model and the type of machine learning that is chosen, is all a value-laden decision. So these aren't a given, and we should ask why this data, why that model. As we just pointed out, Conrad pointed out that some of these are more inscrutable than others, and so that's a value-laden decision. If we have something that's overly complicated, could it be that we don't need it to be that complicated so that we could then explain it or have it be contested later on? One also thing to remember is that what we're doing a lot of times is admitting people or passing people, giving A's to people who looks like the people that we did in the past. Only, as my favorite computer scientist corrects me, we are aggressively reproducing whatever is going on in the data. So it's always something to remember that we are doing it faster and easier, but it's aggressive. And so we can also aggressively be making mistakes. There's always problematic proxies that we have to watch out for, especially around socioeconomic And then watching the labels that we use to label people, because we are talking about students and individuals. So when we talk about someone that's non-recruitable, what does that person look like? And do we want to have that title and that label for that person? Because I'll talk about in a second, this can get repurposed later. Second, what does the data look like? So one thing I always like to push back on is when someone says that it's an objective piece of data, that we're really talking about is something that's easily quantifiable. They're all value laden, they're all moral judgments that go along with these pieces of data. And so we need to remember that this is just what's easily quantifiable. Second is someone who I like to use in this case, which is actually Michael Walzer, who's a justice philosopher. And he has an idea around the spheres of justice, which is easily explained, probably easiest if he doesn't want any good to be distributed, so admittance into college, to men and women who possess some other good, say wealth, merely because they possess wealth and without regard to the meaning of admittance into college. And so he thinks of this as you can win in one area of your life without having it influence whether you win in another area of your life. And the reason I bring this up is that when we have larger and larger data sets, you're more likely to pick up kind of proxies for winning in one other area of life and be using it accidentally in your machine learning model to predict success in another area of life. So there are many issues with large data sets, large meaning not the number of individuals, but large as in the number of variables or the factors that we consider. And I think Walzer is another reason to question that, because we're more likely to pick up proxies for winning in another area of life that we do not want to infect an admissions decision or a decision around mentoring or guidance counseling or whatever it might be. So third, how is accuracy measured? I think this is always hard with predictive analytics. For whom is a metric or outcome not accurate is always a question. And I would ask, where can predictive analytics go wrong? You can either not predict the outcome variable very well across different groups. The other question is, does the outcome variable, is it really good at capturing what we like to call the phenomenon of interest? Meaning, is GPA really a good outcome variable for success in college? Now, GPA is usually a good one, but you can find reasons why the outcome variable is an easy thing to capture, but isn't really the greatest measurement of the phenomenon that we're looking for. And so it's always good to question that, especially when we're picking an outcome variable. With predictive analytics, however, there's another issue that we find, which is it's really hard to measure whether you're successful or not, because we almost immediately, in categorizing someone, give them a treatment. So, for example, we're worried about some people not being retained. So that retention is an issue that we talked about. We would immediately then advocate for some sort of intervention along those lines, and then we could see at the end whether or not we were successful in actually increasing retention or decreasing retention. But the issue isn't necessarily is that it's really hard to pull apart the influence of the treatment effect versus how good of a predictive analytics model that you actually had. And so normally in science, we would actually pull these apart, right, by having a control group and another, or testing it on testing data. And this is only to say that whenever we're doing predictive analytics, we really need to ask closely as to how are they measuring accuracy or success. So when anyone, an ed tech company or anybody says that this works, and I always put that in quotes, you always have to say, like, how are we measuring that it works or not, and how do you know that it works? And so, and this is particularly difficult when we're giving a treatment on top of the categorization right away. And so finally, and this is a concern that I always have with models in certain spaces in policing and also in education space, how could this program be repurposed? And so we actually have a good example of this. We could have an area where we're trying to help for retention, which is an admirable goal, that we identify people who need additional help to make sure that they're retained. Now you could imagine that getting in the hands of admissions, and it was mentioned by Michelle that one of the things they look at is retention. And so one question is, looking at it for inclusion, and I'm using Michelle's words here, who needs help for retention? And could it then be pulled over to admissions and ask, well, who should we let in? We don't want to let in people who aren't going to stay around after a year. And so this would be the issue of repurposing for exclusion versus the original design that we might have. You can see this with the difficult to recruit becoming just non-recruitable, kind of the idea of just letting them go. And I liked Michelle's phrase of being used to include versus used to exclude. And we shouldn't think that this couldn't happen. There's a great example of an elementary to high school, actually middle school to high school program in Tampa Bay, Florida, who had identified and predicted people needing mentorship, people who are students who are at risk. You're talking about 10 and 12-year-olds all the way up to 18-year-olds. But instead of providing a guidance counselor or additional mentorship, they actually just gave those names over to the police so that the police had more information from their school records that could help them actually monitor them more from the police standpoint. So the idea of repurposing machine learning for exclusion versus inclusion is not an idle one that we need to worry about. We really need to be careful about how things are labeled and the purpose for which we design them. Okay, so potential benefits and costs. I definitely focused on the costs and the unintended consequences, but I would just say always ask, what are we measuring? What data does it take, and should we be including this data? How is accuracy measured? When they say that it works, what do they mean by working, and how are they measuring that? And also, could this outcome or target be repurposed? Could the whole program be repurposed? And to borrow again from Michelle's phrase, for exclusion versus where we're targeting it for actually inclusion. So I really appreciate the opportunity to talk about this. I think it's hugely important, especially because we're talking about students and humans when we're talking about AI in this instance. And so I really appreciate the ability to talk about this, and I look forward to all the questions.
Thank you, Kirsten. And at this time, I would like to invite all the panelists to put their cameras on. Great points about how we actually measure whether these algorithms are working and the potential dangers. And so I would like to invite the audience to send questions in, and we have one already from Tanya Innes. Based on the detailed review of the emissions research that Dr. Paulsett shared yesterday, what is the approach to use AI and mission algorithms based on the findings of that research?
So I can take a crack at that. I think that one of the things that's happened with AI lately is it's gotten so much press attention and it's gotten so much coverage that people really aren't familiar with how far it has to go before these things get deployed. So even though that research exists, I am not aware of really any institutions that are seriously considering, a super advanced sort of decision-making or reinforcement learning or AI type mechanism to actually make decisions. The other thing I'd like to point out that I like to remind absolutely everyone of when we're talking about admissions is that the media focuses so disproportionately on 20, 30, or 40 universities in America. And those 20, 30, or 40 universities in America are not representative of what the entire college landscape looks like. So, there's a great article that was written on 538 called Shut Up About Harvard. There's like this ongoing joke in admissions about how much we talk about selectivity above everything else. But it's just a really important reminder that 80 or 90% of colleges and universities in the United States, including four-year ones, I built a chart and I looked at it the other day, 80 or 90% admit roughly 80% or more of their students. So as important as I think this conversation is, and what Conrad was talking about is so fascinating and important, we need to remember that there really isn't a huge space for people to deploy these kinds of models for the selection process. I think there are opportunities to use various forms of advanced analytics for pieces on campus. And as Kirsten mentioned, those can go horribly wrong. So we need to be careful. But this whole AI making decisions at selective universities is not happening right now and probably not presumed to happen in the very near future. And the third point would be, even if it did, it would only impact a very small number of institutions and schools because most places let in roughly everyone. I hope I answered that question in some way.
Thanks, Brad. And
Absolutely.
feel free in the audience, if you want to do any follow-up questions, you can do that. So recently there's been a documentary in Netflix called The Social Dilemma, and it talks about how social media is used and AI is used to influence behavior. A lot of it was negative. How could AI tools be used to positively influence more students to enter engineering, and what are the ethic issues involved with this approach? Any of our panelists would like to take a stab at that?
Sure. I think it's a fascinating question, and I know that there have been studies, large organizations doing these behavioral aspects where they do predict that an intervention would have a certain response, and actually does. It seems as though echo chambers is really what the challenge is when it comes to social media, where individuals have their initial belief systems that then get reinforced with people around them. It would be very nice if students started off with the belief that STEM education was the future, and then just use AI to reinforce that. However, my experience has been that it's the opposite, where STEM education, in popular culture isn't perceived as cool, and a path that is inclusive for everyone. And so it seems like more of an uphill battle to then get behavior change. And I'm not sure if AI can be the silver bullet that kind of solves that much larger societal issue.
So I'll go ahead, Kirsten or Michelle.
Go ahead, Kirsten.
Oh, I was just going to say to Conrad's point, I think hyper-targeting through machine learning, where you are able to identify an individual and kind of see if they're going to, or maybe even just micro-targeting instead of hyper-targeting, would be the attempt to persuade them on an individual basis. But to Conrad's point, I think when you're trying to get to 14 to 18-year-olds, it's more of the, broad campaigns that make smoking seem uncool, so that other people agree with you. Because if I were to get Conrad to agree that STEM is cool, but I'm his friend and I think it's stupid, and and I keep telling him that. So I don't know about the even micro or hyper targeting of teenagers to sway them, especially if you're trying to persuade like a group of people. That's not to say they couldn't be used for other reasons, but as a persuasion campaign, I'm not sure it's the same as like buy this mattress versus another one. You're really trying to change their mind about whether they can see themselves in STEM. Now, it could be that you could target certain, but I don't even know if you need to hyper or micro target based on like physically seeing females in STEM if you're showing it to my daughter. You know what I mean? Like, so that might help, but you really don't need machine learning for that. I would think that you could do that without it. And I'm always hesitant to say micro or hyper targeting should ever be used, because if it gets out that a university has all this information about an individual and was trying to manipulate, then there could be a lot of blowback that's not even worth the benefit that you get from it.
Those were along the lines, Kirsten, that I was thinking. And whether it's, you call it, advertising through social media and geofencing, or all of the different things that people do. And yet I do think early exposure and representation matters. And so I think, in many cases, it can be very positive. And I think that's why we have MESA programs and why we have the Gear Up programs, is really trying to expose students to our undergraduates, our grad students, and our faculty, so they can see themselves and consider this as an option. And I think, Andrew, along the lines of your Netflix, and I don't know, maybe everybody here has seen it, the Coded Bias, I recently saw that, and I think I shared with our panel members. If you haven't seen that, I thought it was very good, very insightful, and just really gets you thinking. And I think it's critical. And Kirsten, it's been so great working with you. And before people get too far down the path, following your advice, really thinking about the unintended consequences, because even with the most altruistic efforts, Conrad, just your example, you can think you're doing something really good, but if you're not really, really conscientious and, really trying to test out your own assumptions, I think it can, create, again, significant unintended consequences. And I think, I love the work with our faculty and talking about what is appropriate use, because you could easily think of all of the ways that some of this could be, really construed in an inappropriate fashion. And really being proud of what you're doing and why you're doing it. But even if you think it is the best, I think, keep looking in that and making certain that there aren't any unintended consequences.
Thank you, Michelle, Kirsten. There's another question.
If I can
Go ahead,
throw
Brad.
out, if I can throw out the boring answer too, the question specifically says, how could AI or ML assist with holistic review? And for those of you who have done holistic, tedious, boring work that takes, and AI is especially good at, currently at least, at doing repetitive tasks over and over and over that don't require difficult classification problems like the kind that Conrad was bringing up. So, you know, I know it's been used in like law firms and it's been used in financial firms to just do these like mundane tasks that humans used to do. So I think it probably wouldn't play into the selection process, but it sure would be awesome if we could have algorithms, say, manually read transcripts, try and understand what those different classes are, try and provide some context around what courses are and what the grades are, so that when a human finally comes in there to look at it, some of that initial incredibly tedious, really boring work is already taken care of. So I think AI could help us set the table for humans doing better. But AI making the decisions, I think I would be super skeptical of. Out of hand, I would be concerned about that.
Well, and I might add, if I can, Andrew, a little bit maybe different perspective to that, because again, I think it's really intriguing when you read a student's story and kind of their history. And one of the things that we've done in the past is we had one holistic review score, and the faculty literally this morning, we're going to be discussing it, that maybe we want to separate out, and this is a maybe, you know, that achievement within context score and a non-cognitive variable score that's a little different. But all of those are reader scores. And the readers read to score, they're not reading to make any kind of admit decision. And so kind of separating that then to then have this additional piece of information, whether it's, again, I think, Kirsten, your point, whether it's a predicted first year GPA or retention that may or may not be used kind of at the back end, but it's all of these really leveraging what the readers are seeing, what the readers are learning. And so I think for our campus, that's something that I don't think anytime in the near future we would be interested in the machine learning for that leadership experience, for that academic, and yet having this other, you know, data factor that may or may not be used. But I think we would be far stretched to kind of turn over the non-cognitive variables or the achievement within context to any kind of machine learning in the near future for certain.
Okay, thank you. The follow-up, I guess when someone asks how could AI ML algorithms assist with holistic review, they said, for example, Dr. Reed illustrated how high school leadership was a good indicator of success for women applicants to engineering. I think, Michelle, you answered that question, that part of the question. So another question is, EdTech companies are offering sometimes unsolicited advice to institutions. What advice do the panelists have for vetting them and sharing concerns with administrators who might be interested?
So we talk about this in my class all the time. I think I always say there are two areas that concern me. One is ed tech and one is law enforcement tech. And both times, a lot of times the procurement officer isn't necessarily, focused on being able to answer or ask the right questions of the tech company as to what exactly is going on and how is success measured, how is accuracy measured, what type of data, those types of questions. And this is not only at the university level, but at the high school level on down. And I'm always surprised. I was at the National Academy of Education for a talk, this is like a few years ago, and how they actually conflated academic researchers with ed tech researchers, and they see them as the same thing. This is at the high school level. And so I think that we should not treat ed tech like academics. They don't go through an IRB. They come in and they are trying to sell you something. And I think that there needs to be more focus on the procurement process around ed tech to ask better questions. And that's just to put it in perspective, like when I was a quote normal person, before I was an academic, when I was just out of engineering school, I used to work in systems consulting where they would bring us in to actually advise purchases of systems, like so big computer systems. And the reason is that even though they were in IS and in I don't know, Sunoco Oil or the mining company, they were not aggressive in asking questions about what exactly was going on. And they used to, but now the purchase is so much cheaper that it doesn't make sense to bring in someone from the outside to do that. And so that's part of the issue, is that we don't give enough, because the purchase is smaller, it's not as much money. we don't spend as much time and attention as to exactly what the technology is going to do, and we're buying things, quote, off the shelf a little bit too much. So I actually think that that's a great question, and that there needs to almost be an expert that you would bring in, whether it's an outside expert or someone in the university, if you're big enough, that really asks those good questions, and that, you know, so get someone from CS Engineering to come over and start asking questions that makes the ed tech salesperson feel uncomfortable. I mean, that I would be very, very pointed about it, and bringing in someone that asks almost hostile questions is a good thing. Apologies to the ed tech people out there right now listening, but you just have to be really, really careful, because they're literally, you're on the hook as the university for all the values, norms, and laws that govern admittance and treatment of students. If they're off by a bit, they're aggressively off, because you're going to start using it, and then you're in trouble. Like, you're still responsible as if a human did it, and they are not. It's on the university.
Yeah, I think that's great, Kirsten. And I would only add, and I think that it almost goes without saying, but want to be very intentional, is find out who they've worked with previously and talk to those institutions, because I can't tell you, I think all of us have had experiences that something looks great, you know, on paper or in a fancy presentation, but it may not be delivered that way. And then I know we have a really significant security addendum that has to be reviewed even by our legal counsel and by our privacy department. And so I think, Kirsten, that goes back to yours as an individual. I don't want to be solely reviewing those. I want to make sure to work with the team who's going to really vet this and kind of poke holes in it to see if it makes sense or not. But I think you have to be honest with administrators, which I think this is key, because sometimes administrators are looking like, oh, I saw this. I was at a conference. And I always joke with our, and I think Daryl might be on with our president or chancellors, like, I don't want them to travel because they come back with, I heard this or I heard that. But you have to just be really, I think, open and honest that, you know, here's our process, because I think anytime somebody rushes something because they heard this or that, I think that's where there's even more risks. So having a clear process that you vet any, you know, whether it's ed tech or anything else, you just have to do your due diligence, because it is a big investment and the risks can be high.
I came from an ed tech company, and I would say that they can provide a lot of value, because institutions have a hard time building these things internally. They have a hard time getting the focus. A lot of times the price seems right. But my advice would be to be extremely skeptical. And I would also suggest to make your contracts very short. And what Kirsten said is so spot on. Bring in people. I've actually had a bunch of fun coming from ed tech back to a university where I get to kick the tires on all these things. And now I get to be the annoying person who talks to the ed tech companies and are like, demonstrate how this actually works. And I get to ask those hard questions. But there's kind of a joke in Silicon Valley land, which is whatever someone shows you, believe that it's actually going to deliver about 20% of what they're actually saying. And I think for ed tech, maybe dial that down to like 17 or 18%. But I personally have been on both sides of that, and this is a conversation I could have absolutely all day. If any of you have questions or want to talk further about it, this is an incredibly interesting space. And so thank you to whomever asked that question. It's a very good one.
Brad, there's a comment in the Q&A that says, regarding Brad's comment that we let everyone in, how do we reconcile that with needing to improve admissions policies?
Yeah, I would say when we focus on selectivity, we're focusing on the wrong thing. Focusing on inclusivity and making our recruitment processes grab people who wouldn't normally be involved in, wouldn't be candidates for higher ed or wouldn't be candidates for engineering program is a whole separate conversation. But the press just loves talking about selectivity. Oh, Harvard got 150 million applicants this year and they only took 4. Like, who cares? I think we can talk about the millions of high school graduates who could do great on our campuses who haven't even been invited to the conversation. And so that's how I would answer that question.
So I have a question for, go ahead. Go ahead, Michelle.
Well, I think, Brad, you just hit something, and I think you even asked about this recently. And, I think everybody knows with the standardized tests going away, some of it was related to COVID, but for the University of California, our regents made a decision. There was some big litigation, and one of the things that our faculty did is they did a big research, and the test was certainly one concern, but of equal concern is like similar to what you Brad was mentioning, who has access to the college prep curriculum. And so that is equally as concerning, and even if not a little bit more concerning than even the test, when our faculty really reviewed this carefully. And so I think that whole notion of, who is being invited to the table, and our work with K-12 has to continue to get, really working closely together, this intersegmental collaboration about who gets invited. So I think, the admissions policies, that's kind of related to it, and it's not a policy necessarily, but how do we work more closely with K-12 to ensure that all students have access to that curriculum? We call it A through G just because it was literally a policy A through G of your English and your math and your sciences. But I think that's something that's really critical. And so some of that can be policy at, the K-12 level, not even just at our level. And so that's something that's really near and dear to me, that, yeah, we may have resolved something with, not using standardized tests, but I'm equally as concerned. And then think of the grades. We talked about this, what does a grade mean, and who has access to higher grades, depending perhaps on the type of school you go to or your family's income or zip code. And so even without standardized tests, I almost worry that it could be higher stakes now because we don't have another factor. But I think we all know there were certainly issues there, but same issues, like who has access to those courses to be really prepared to be successful, and then the grades in those courses. And that's why that context is so critical.
So thank you. So I had a question for Conrad. So recently I read that the European Union is proposing restrictions on certain types of AI. And they point out one of the areas was college admissions. Do you see the U.S. Doing something like this or something similar in the future?
So yeah, that's a great question, Andrew. And I think Europe has just, in terms of awareness of privacy in general, GDPR passed a few years ago. Contrast that with other nations. I don't think that that we're anywhere near that there yet, and it's just because of how lucrative data is for many of these big tech companies to then change these policies that limit access to the data for these companies from an advertising point of view. I just don't see that happening anytime soon. I think maybe what we can hope for as an initial start would be more awareness of the general population in terms of the value of their data. There are discussions now having, in essence, like a nutritional label that we have for foods, but we have for algorithms. Imagine how transformative that would be to shift the decision-making to the end user, so that, if I do get rejected from a college, or if I don't get financial aid, I'm able to look at this label to see what were some of the ingredients that were used that led to that decision. I think there's just too much, opacity or lack of transparency in the process right now, where it's just a binary decision that individuals have access to. So I think from a policy perspective, there are things that we can do right now, but I think Europe is definitely further along in awareness and thinking about these problems.
Well, thank you. We have a question from Tom Ferris. Agree that more applications that are not admitted is not useful. How do we get this out of university rankings? I'm not sure how this pertains to this conversation, but does anyone have thoughts on that?
Question. That's what I thought.
Yeah. No idea.
Okay.
I would like to chime in and just provide, I think we talked about this not too long ago about just the mismatch in incentives, right? So what are the administrators that are reviewing applications, what are their reward systems? Contrast that to faculty. What are our reward systems, or a department head, or the university itself? I think some of the challenges that that occur stem from these misalignments and in the different incentives and reward systems. Why should retention be the metric that drives the decision of an administrator to accept or reject an applicant? And if that's the metric that person's going to be evaluated, then they want to minimize their risk and just select the students that have the highest chance of succeeding. So, if we maybe go back to the reward systems and metrics themselves, maybe it might incentivize different behavior.
That's a great point. In my exercise of doing this in class, I actually ask a group to take the role of development and how would they want admissions to look? And their target is, how much are you giving 10 years after graduation? And then all of a sudden that drives to say that each group has their own focus, and someone who's focused on, percent admitted is going to try to widen the pool blindly and give a lot more applications so that they can have a lower admittance rate. And it's also why they look at matriculation rates, because of the rankings. And so I think that it is important to always question that outcome, and also the other factors that they're taking into consideration as to, well, why? Why that outcome variable? Well, that's how we're ranked. Well, is that really the best thing for our school? You know what I mean? That's the question, because that can be as Conrad puts out, a mismatch, in that it might not be the best thing for the university's class, or even the strategic direction of trying to broaden who's included. Because whoever's teaching Calc 101 wants everyone who already took BC Calc in high school, right? I mean, so there's an incentive. They're not good at figuring out who else they could teach. And so I think that it's a great question as to why that outcome variable is being chosen, and it's very true that we have competing interests.
Yeah, I love that, Conrad. I'm glad that you really mentioned that. And I think again, as I mentioned, our Academic Senate Committee on Admissions and Financial Aid does, their bylaws, the admission policy for undergraduates is theirs. And so we work together. So it is administration working with the faculty, but ultimately it's under their purview completely. And so I think sometimes that division of duties can be really, really beneficial when you really think of, who's going to come, because I think there are such risks with this in terms of who's driving, because I think, Kirsten, your point, some of the faculty may want all of those students, and yet our Faculty Senate Committee, since I've been there for nearly 15 years, is very focused again on excellence and diversity, and having those really heartfelt discussions with the faculty each year, like, what does achievement look like, and what does this mean for Santa Cruz? And they have their selection principles. And as I shared, they really are keenly interested in students who can benefit from a research university. And so that pivots us, of course, going in one direction, because it's not going to be just, reading and scoring and drawing down the line and here's the cutoff. It's really true enrollment management and shaping the class of, again, I think still focusing on the future alumni. It's all about success. And yet, how do you define that? And I think you have to have some of these really robust discussions with the faculty or whoever's running that policy, that, what does that really look like? And it's a really fascinating discussion every year, and it depends on which faculty are serving on that. But I think the rewards, whether it's a chancellor, president, or provost, that's where things can really get, I don't know, I'm going to say derailed if you're not careful.
So this is the idea of broadening the applicant pool actually brings forward a great use for machine learning or AI in this way, in that it's not realistic for admissions organizations or departments to look through a 5-fold increase in applications over the last few years, if you include the issues of Common App and dropping the test requirement. And students apply to more and more schools, and so admittance rates are going down further and further. I mean, just everywhere. So it's not just selective schools. It's just people are just broadly sending things out. And so I think that there would be a danger in not having something to help us with a more comprehensive review, that we would just be looking at whatever the shiny object is, the SAT versus GPA score, matrix that we all know and love, that you'd just be looking at like really primary indicators. And so this is a way that you could actually be more comprehensive on a larger data set, because it becomes untenable for humans to do it. That's one reason to actually think through how we can do this well. The other one is from a question that came up earlier, which is, what about the idea that it turns out women or girls in high school that took on leadership roles actually did better in retention around engineering? So that's not surprising. I was a female engineer undergrad, so it's not surprising to me, but I think that's the kind of analysis that actually a good use of these types of machine learning models is that, similar to economics, where you can actually identify what exactly is going on, and economic modeling, which is boring as all get out, but at least it forces people to say, you know what, these are my assumptions and this is how I'm making my decision. When we come to actually analyzing who are we letting in, you can find those types of patterns in that. If you were just asking humans to do it, they're not going to pick up on that idea. But you could actually go through and be very targeted to say, with a group of females, and just look at that data set. And here's ones that made it, and here's ones that didn't. How do we make sense of just this? Like, what were the driving factors? Or if you're looking at different minority groups, so you could look at who's underrepresented, who made it, who didn't, and just focus in on that, and really try to unearth like different things that were driving retention that we weren't see as humans. And so if we're doing it for those purposes, I think those are more to Michelle's excellent point earlier, around inclusion versus exclusion. Like, you're trying to say, what can a human not do with this large data set, and what little nuggets can they unearth from it? But that's very much having a human still be a major decider, and what they like to call the human in the loop. So actually having the human still be involved and using it for machine learning for a very strategic purpose. But I think you have to, because the admissions is just getting untenable the way it is right now with the number of applicants.
Yeah, that's the very argument I was trying to make in my talk, is essentially build a model, understand who is most likely to do the thing that you're interested in and who's least likely, and then point your human beings toward the students that are most likely to need help. Point your human beings toward the outcome that you care about. And I think that it's just so easy to just flip these things on their head, and all of the sort of concern that we have about bias, it's legitimate and we should pay attention to it. But we can predict all the people who are, overrepresented and likely to come. And with just a little bit of human intervention, you go, let's find all the people who are underrepresented and unlikely to come and tackle that problem. And that same model with that same probability distribution. I may not have done a very good job in my talk, but that's exactly the point I was trying to make, is use predictive models to optimize your resources, to make your campus run smarter, to make your campus run better. But don't point toward the easy things, point toward the hard things and put humans on that task. And I think that we can ideally strike that balance where a model helps us rather than is just some what I refer to as the crock pot, where you throw something in there and then dinner is done later. Like, don't be lazy with your models. Think about how you're actually preparing for this conversation. And ideally, we can use data to, like the analogy I gave, which is maybe kind of goofy and dorky, but is, to use it as a flashlight to find those handful of students who need the extra attention and to allocate those resources accordingly.
No, I think it was a great point. I was more just linking it back to the question earlier about girls at the time, so students in females that were in high school, and how can that link back? But it's a good example of like using machine learning as a flashlight to find people not only that need help, but this is how we could actually identify people who will stick around and who are underrepresented in engineering right now, or
for sure.
We are.
So we've talked a lot about the recruitment and admissions. What about retention? How could AI be used for retention, or how is it in some of your institutions?
I guess algorithmic AI could possibly be used for identifying students that are at risk of dropping out or failing a course. But in order to have that type of behavioral trajectory, you would need access to multiple dimensions of data pertaining to that student. And I think this is really where the challenges of privacy that you alluded to earlier, Andrew, and performance come into play. Are students or parents willing to share that much data about the behavioral aspects of a student that may be predictors of when they may be experiencing mental health issues or issues that may increase their chances of having challenges throughout their academic career. It's not just failing a course, right? There are many aspects beyond just a numeric score on an exam that could have led to that. But in order for an AI to be able to have any meaningful impact, then access to that data would need to be provided. So I think that's where some of these challenges would come in.
Yeah, I think it's a really important question to be asking. And I kind of am on that point, and especially this year, like I think about this incoming class of fall 21 who's been doing remote work for almost a year and a half, and there were so many inequities in K-12 already, and now that's been exacerbated by the inequities through remote learning. And so I'm trying to create a greater sense of urgency to try to leverage even some early indicators, and whether it's again a predicted first-year GPA, and again really thinking of it as that support level. And I think of our academic advisors who may have, and I don't even know, I'm going to make up, I don't know if it's 800 students, and again, you can't maybe call everyone, and maybe 90% are fine with that email and they can navigate because they've got those executive functioning skills, they've got that social capital. But there are some students, maybe it's you identify the 10% and some of the intersectional identities based on the information you have available, that, that phone call to say, hey, I just wanted to welcome you to campus. I'm your advisor and I'd love to have coffee with you. Something like that. You're not necessarily saying, hey, Andrew, I see you have a low score. Let's get together. But you just make that personal connection. And sadly, like, you say, Brad, we don't have the resources to maybe do that for every single student, but wouldn't it be great for that, smaller percentage to have that? And again, some people call it like intrusive advising, where you're trying to maybe anticipate and stay a step ahead, but just helping them understand where the Career Center is, because making education relevant is so critical to student success. And I just think there's an opportunity to use some of that, what you call, whether it's one-on-one or personalized attention, and using that as a support level indicator more than anything. And, this year, I think that for our campus is going to be more important forever. And I think maybe on all campuses, because the learning has frankly been drastically different in the last 18 months.
One of the things I like to point out, first of all, I think the retention space is just way more interesting and fun to think through. I mean, there's so many different problems you can tackle. But one of the most interesting things about sort of setting these machine learning models on your retention problem is that oftentimes what it's going to do is, algorithms are dumb. They're just computer code that are sorting through a problem mathematically. And it is going to unearth very quickly all of your weird business processes and all of your weird dead ends that you make students go through. So especially if you use some sort of unsupervised technique, you're going to say, well, what are course pathways that make it through? And you're like, yep, everybody who gets into that class fails that class. Or we have this disproportionate number of students who seem to be successful, and then they hit a decision point where they take class A rather than class B, and then they become way less likely to, persist or graduate. And that's where you pick up the phone and you go, what is going on with this class? Why are students failing this at such a high rate? And then usually you can get a pretty quick answer, talk to 5 or 10 students who have taken that class. So in the retention space, I think, there's like this, there are a lot of these interesting sort of AI machine learning opportunities, but one of the things that is a great opportunity is to use it as a mirror on your own campus and to sort of help you understand where all of these pathways kind of go wrong. And oftentimes you'll find things that you already know about, but now you have a little bit more sort of data support. But it's also a little bit hilarious to see an algorithm come up with the exact same thing. And you're like, yep, calculus is hard. Yep, females don't do well in this physics class because this professor has been teaching it for 30 years and has a particular pedagogical method. Everyone on campus knows it. You could buy 3 cups of coffee and find out the same data, but your algorithm will find all of those sort of bumps in the road. And I think it's a real opportunity to be like, how can we make our physics curriculum more inclusive? How can we make our math curriculum more accepting of different students or whatever? So have fun with that. I'm sure you'll discover all your own goofy corners of campus that an algorithm discovered for you.
So we have about 3 minutes left. And so I want to give everyone about 40 seconds to give like your last takeaway that you'd like to give to others, especially those who came to this session and don't know a lot about AI or machine learning or data science, and maybe they want to use it or they're not sure, or what are your last words of wisdom? Start with Michelle.
Yeah, I would say really educate yourself on some of the topics that we've discussed. I know that there are some great articles, there's some books, the movie, again, it's a short film, I think it's about 90 minutes. And, you know, challenge that when you have conversations, feel free to challenge those conversations. But again, I think working with your faculty, working with institutional research, you know, finding out what's currently happening on your campus. And, but I think you have to kind of become a, you know, steward of this discussion, or almost a student, to make sure that you're really questioning and really seeking to deeply understand the potential benefits as well as risks.
Conrad, thank you, Michelle.
Thank you, Michelle. And I'm going to start with the risks. I think that Michelle highlighted one of my concerns with just the way that AI is portrayed in the media, in movies. It's become this blanketed term that means everything from, you know, simple equation now to complex neural networks. So to Michelle's point, I think the first step would be educating yourself to what it really means for an algorithm to make predictions or classifications. Many would argue that we really don't have a true artificial intelligent anything right now that rivals human kind of general intelligence. But that's okay, as long as we understand what the limitations of these systems that we're using, and not get too obsessed over correlations that may be discovered and confusing them to be causal patterns. And I think those are part of the education that needs to happen. So thank you very much for having me. It's been a great learning process and engagement with my colleagues.
Thanks, Conrad. And Brad.
Sure, I think I can make quick work of this. We have to use data if we're going to operate efficiently and effectively as institutions in the public trust, but we also have to be transparent and concerned about how data might be used, particularly in model specification and predictive models. And I think that there are plenty of opportunities for us to do better. But of course, as others have pointed out, there are plenty of opportunities for us to take on risk or to disadvantage students who have been previously disadvantaged. Last but not least, be skeptical of edtech. And I would also just like to thank this group of luminaries. It's been incredibly fun to share time with you all, and I look forward to future conversations. Thanks so much.
Thank you, Brad. And Kirsten.
I would say to pick up where Brad left off about edtech, you know, it's not just edtech, it could be homegrown, is to always ask why that data, why that outcome variable, why this, was it trained on data that looks like mine? Under what conditions does your model work? You know, these are things that a computer science or a data scientist should be able to answer. And if they can't, then that is their problem, not yours. They should be able to explain that to you in a way that you can understand, especially because you understand the business of education and they understand their technology. So just like you can explain academia to them, they should be able to explain it to you, and always ask those whys. If they just say, this is how everyone does it, or this is the best data, then you should just keep asking why.
And thank you, Kirsten, and thank you to all the panelists. This was such a great discussion, a very meaningful and important topic. So I want to remind all the attendees, you can provide feedback on the whiteboards in the lobby, and you can encourage, and you can network with people during the break, but be sure to come back for the breakout session, because we're trying to look at discussions on how to talk about the barriers to using these tools and other tools and envisioning the perfect admission systems. Thank you all. Enjoy the rest of your day.
Thank you so much. Take care.